All right, 7.5. This has got a lot to it, so I'm going to separate it into two videos. We'll have an A and a B. The first video, we will do angle bisector theorem and intro to Pythagorean theorem, and then the second video will be all about the geometric mean. So, a lot of fun stuff to talk about here. Objective: students will be able to use the angle bisector theorem to solve for missing parts in triangles. You're also going to have to use Pythagorean theorem sometimes and the geometric mean sometimes. So, let's get right to it. The angle bisector theorem is really straightforward. Okay, it says an angle bisector of an angle of a triangle divides the opposite side, and this is the opposite side here. Here's your angle bisector, and it divides the opposite side into two segments that are proportional to the other two sides of the triangle. So what does that mean? So if you get an angle that's bisected perfectly, so these two angles are exactly the same, this bisector divides this triangle into two triangles that are not necessarily similar. However, this side is going to be proportional to this side with respect to this and this. So we could say this is to this as this is to this. And so we got a little formula for it. And so let's just practice how we would set that up. So we're saying that AB is 5. So let's just go ahead and put in some values in our drawing here. So we got that AB is 5, AC is 6, BD is 4, and they want to know what the length of CD is. So maybe that'll be our X. Well, it's pretty easy. We're just going to do this side over this side. So that's 4 over 5. Has to be equal or proportional to this X over 6. That's all there is to it. So really quickly, we can just multiply both sides by 6, multiply by 6. These cancel, so we just are left with X has to equal 6 times 4 is 24 over 5. And you can plug that in a calculator if you want to get a decimal answer, but that fraction is totally fine. So that's really all there is to the angle bisector theorem. You're going to see different numbers in here. You might see decimal numbers in here. Who knows what, but it's really just that simple. So here's a practice problem for you to try. It just says, what is the length of BD in the triangle to the right? So BD is here. You can make that X. You got two angles that are the same. So just figure out how you're going to set up your proportion and then solve it. I'd pause the video, give it a try, and then I'll put the answers up in just a second. All right, so I know that 4.1 is to 6.8, so 4.1 to 6.8, in the same way that our x value, our unknown value, is to 4.4. So what's happening to my x? It's being divided by 4.4, so I multiplied it by both sides, canceling out the 4.4. And then I just put this in my calculator, 4.4 times 4.1 divided by 6.8. Now on this question, I didn't specify what to round it to, so if it's ever not specified, just do 2 decimals. But most of the questions you'll see, it will be specified actually. Let's say 1 decimal place, 2 decimal places, 100th decimal place, whatever. It'll tell you exactly what they want. So the answer here is just x equals 2.65, or it was really close to 2.65 because I did round here. So that's really all there is to the angle bisector theorem. So let's go ahead and move on to something a lot more exciting. And we're just going to kind of barely introduce it in this section, but we'll talk a lot more about this next chapter. This is the Pythagorean theorem. And basically, in any right triangle, so here's a right triangle, the square of the legs, so you square these legs, and then add them together, it will always be equal to the square of the hypotenuse. And you always can know the hypotenuse because it's the side that is across from the right angle. So that side is always going to be all by itself in this equation. So let's say we had a triangle with sides A, where the A part, or this leg, is 4, and this leg is 6. They want us to find C. Well, let's just plug it in. We would put in, according to this formula right here, I would do 4 squared plus 6 squared equals, the C is in purple. Let's see, do I have a purple? I do. Equals C squared. And then you just solve for C. That's all you got to do. It's actually pretty straightforward. So 4 squared is 16, 6 squared is 36, and we don't know what c squared is, so we just leave it like that. 16 plus 36 is 52, so you have 52 equals c squared. Now you're not quite done yet. There is one more math step that you got to do here, and that is you need to get CL by itself. And right now c is being squared, so the way we undo a square is we take the square root of both sides. So there's c. But over here we have whatever the square root of 52 is. See, these things cancel each other out. But over here we have to see if we can simplify. And this is a skill that we've done a while ago, but I think that you can do it. You want to look and see if there's any perfect squares that go into 52. And basically you could write this as 52, something that multiplies up to 52 is 4 and 13. And 4 is a perfect square, 13 is not. So 4 we could take out of the square root of 4, which is 2, and 13 would stay inside. So the answer for C is 2 rad 13. This also has a decimal answer. You could go to your calculator and you could say 2 times the square root of 13. So I'm going to do that real quick just so you could see what that would look like. You could test it in your calculator, see if you get the same thing. And that is really close to 7.21. So I should use a little like approximation symbols here. So this answer here, this is actually exact because there's no rounding involved here. This is exact. This, however, is a rounding decimal answer, which sometimes will ask for that, sometimes will ask for this. It just depends. So we have found the length of C. It's about 7.21, or in exact terms, it's 2 times the square root of 13. Okay, so that's how you use the Pythagorean theorem to solve for a missing part. Not too bad. All skills that you guys have done before. So let's apply it to something a little bit new. Let's go to the next page. So here in practice number 2, it says find the length of OR. And it does tell us that the diagram below shows that it's a rectangle. This whole thing is a rectangle. Well, if this is a rectangle, you should know right away that all these angles here are 90. And they give you BR, and they give you BO, and they just want you to find OR. Well, OR is the hypotenuse, right? OR is the hypotenuse. So I would go ahead and just label that C. Or you can maybe say up here, OR is like your C. So your formula, again, for the Pythagorean theorem, pretty easy formula to memorize. A squared plus B squared equals C squared. You got your A, you got your B, and you're going to find your C. So go ahead and use that formula to solve for C. Try it on your own. I'd pause the video and then just come back when you're done with this question and see how I worked it out. All right. Well, I just plugged the 5 in for A, the 12 in for B, and I solved for C. 5 squared is 25. 12 squared is 144. The C squared just stays as the C squared. 25 plus 144 is 169. And remember, I got to take the square root because I want to get rid of that little square symbol because I want to get the C all by itself. And so those guys cancel each other out. And so I get C equals 13 because this one is a perfect square. 169 is a perfect square. And so C just equals 13. I don't need any square root symbol or any decimal. It's just nice and neat, perfect square. So that is actually something that we'll talk more about next chapter, but that's called a Pythagorean triple because this is 5, this is 12, and this whole distance here is 13. So that 5, 12, 13 combination is one you're going to see a lot. And so it's a good idea to kind of just recognize some of these patterns because there's a lot of them. But that's a Pythagorean triple because it works perfectly in the Pythagorean theorem without any decimals. All right, I'll do the other part of these notes on the next video.